Hi everyone, thank you very much for joining the webinar. I'm Kay McGuinness and this is Nathan Lawrence.
Oh, yeah.
And we're joined by Matt Blackwell, who's doing the IT. So if anything goes wrong, we've got someone to blame.
Oh, yeah.
I'm going to start by sharing a few slides. We haven't got many slides, you'll be pleased to hear, but just a few. So for the agenda for today, we're going to do a brief introduction to the sensor. How does it work? What makes it calibration free? We're going to explain the transducer, which is the main working part of the sensor, and explain how it's different to what maybe you're used to using for pH, the glass electrode. Then we're going to then move into the main part of the webinar, which is the demo, where we're going to show how to connect the sensor, all the operation, all the menu functions, look at the output string, the health number, some of the maintenance of the sensor, and then go on to look at the user interface. And then finally, we'll have a discussion on the integrations that we've done so far with customers, the future plans for the sensor, and give you a little bit more information about where you can find info and how you can buy the sensor. Okay, so we'll jump straight in to how the sensor works. Maybe Nathan, you can do this bit.
Yeah, that's fine. So how does it work? So when we started A and B sensors, we went out to speak to glass pH electrode manufacturers. I'm sure you're aware of those, deployers and users of the glass pH. And we really want to understand why those glass pH electrodes needed to be recalibrated. Overwhelmingly, the response was it's due to reference electrode drift and reference electrode changes during deployment, which are unknown and only corrected during a calibration process. We sought to solve this problem by making a calibration-free sensor by basically monitoring the reference potential of the reference electrode in real time and without end-user intervention. Therefore, we can correct it. In the picture here, we show a change in pH or outputted pH around 10 hours. But is that really a change in pH or a change in the reference electrode potential? Air transducers carry an internal reference electrode tracker, which tracks the potential of the reference electrode, a number of pH sensing electrodes for lifetime, and a temperature sensor. By plotting the reference tracker potential with the pH sensing electrode, we can see after 10 hours that isn't a change in pH, rather a change in the reference electrode potential. Therefore, we can correct our outputted pH to give us our calibration-free measurement. Our sensor therefore never needs recalibrating. It covers a pH range 2 to 10, has an accuracy of 0.05 pH units, and currently with the version 9 firmware, which is released on the website, covers a salinity range from 0.3 to 40 ppt with a temperature sensor of about 0.1 C. Our reference tracker is really useful. It's multifaceted. It measures salinity, and from salinity we can calculate conductivity of solution as well. Therefore, we can have calibration-free temperature, salinity, conductivity, and pH.
Brilliant, thank you. Maybe if I put U-tools on, you can talk about how it's different from the glass electrode.
Yes, exactly. So why are we different? Well, obviously we are calibration-free. We're all solid state, so this is one of the sensors here. Completely solid state, no glass involved at all. Therefore, it's robust and stable. You can drop it, it doesn't smash. Also, it doesn't need to be stored wet. It can be stored wet or dry, just leave it on the shelf. No difficulty there. When you deploy it, just turn it on and throw it in the water, and it's good to go. We have a number of sensors in our range, all around depth profiling. We have the OC1250, which is shown here. This is the titanium house version of the sensor. OC300, which we'll be doing some of our demos with here, which is shown in this one. And we have our 5 and 50 meter sensors. AQ5 and AQ50s are rated to 5 and 50 meters respectively. These are all pigtailed. So these pigtails here just relate to the communications and the power to the sensor. If we look at the OC300, this is a 6-pin subcon connector, 2 for power, 2 for RS232, and 2 for RS485. In today's demo, we're going to talk to the sensor through the computer that Kay has over there, through a data transfer unit. The data transfer unit is simply a way of powering the sensor through the USB port of the computer and converting their 232 signal to a USB signal. In the demo, we're just going to plug the subcon connector into our OC300, just screwing on the end cap, and then we're just going to apply power to the sensor through the DTU. The sensor beeps on startup as it goes through its initialization process. If you buy an AQ5 or an AQ50 and you wish to use a data transfer unit, we supply a converter, pigtail cable converter, where you just really simply plug these onto here and then plug this end into the data transfer unit. Obviously, if you have your own 232 and power or 485 and power systems, you can talk to the sensor directly yourself. So I'll hand over to Kay to talk about utils.
Perfect, thank you. So I hope that demonstrates it's really easy to connect up. And then I'm going to show you how to access all the menu options in the sensor. So I'm just sharing my screen. Okay, so hopefully you can see this. This is the A&B utils program that you can download from our website. It's all free of charge. I can show you where to get it from later. The utils program opens up a log file when you open it, so, and saves all the data on the desktop. So that's another good feature. So when you open utils, you get a choice of COM ports on your laptop or computer. This one I'm going to choose COM6, yeah. So I'm going to choose option 3 for COM6. It finds the serial port and finds the baud rate of the sensor automatically. And then it comes back with the main information of the sensor, so the system type, the sensor type, so this is an AQ50, the serial number, and the firmware versions that you're running. We should also say that the serial number now can be found on the sensor. We've put some new nice stickers on, so it's easy to find the serial number. So when you open utils, you get a main menu and you get 3 options. You can install new firmware, download the data from your sensor, or access a command line prompt. So the install new firmware is hopefully very easy, very intuitive. You click on option 1 to do that, and then it just asks you a series of questions. You just go through them. It automatically downloads the data, downloads the firmware files from the website. So it's really, really easy for the end user to do themselves. The downloading data from the sensor, again, is very straightforward. Just follow the instructions. But now I'm going to show you the command line prompt where we can access all the menu options. So I'm going to choose 3 here. And the splash screen of the sensor comes up. You'll note that there's no date or time. So utils, if it sees no date or time, it automatically sets the date and time to that of the laptop or the computer you're using. So if you wait a few seconds, you'll get a new splash screen with the proper date and time. So that, again, there's all the information about the sensor, the firmware versions. And now we can type menu, and we can access all the menu functions. Maybe I'll make this a bit smaller because I think it might be going off the side, is it?
So, yeah, that's right.
Is it?
Yeah,
okay. Put it back then. Okay, so the menu of the sensor is separated to 3 different types of functions. You have the system functions, measurement functions, and data functions. And we'll go through each of these in turn to explain them. But basically, you need to type whichever function you want, and then it allows you to access the function. So for example, if I type version, it gives me the splash screen that you saw before. Okay, so we go back to the menu, type in menu, and we get back to there. Okay, so version gives you the splash screen where you can find the serial number and the firmware revisions. Time, if you type time, it allows you to change the date or the time yourself. If you type mode, you can change between controlled and autonomous operations. And maybe you can say something more about that.
Yeah. So as Kay said, this is the difference between controlled and autonomous. Controlled is if you're hooked up to a terminal system where you can send a scan command to the sensor or a measurement command to the sensor remotely or on the laptop. Autonomous is where you have no control of the sensor, so you can set this mode, basically power the sensor up, and the sensor will start monitoring on the predefined measurement intervals that you've programmed. And we'll talk about those measurement intervals as we go through the functions. But simply, if you hook this to a battery in autonomous mode, it will start monitoring itself and collect data all on the internal SD card of the sensor.
Okay, so I'll keep it in manual control for now. So I'll type in 1 and get to manual controlled. So back to menu. So that was mode. If you type board, it allows you to change the board rate. We have a few customers doing this, don't we?
Yeah, so this depends on your data transmission rate. From the factory, it's set at 57,600. We go everything from 9,600 up to 11,500 and variations in the middle. So we're quite adaptable and we use most common baud rates that we've seen on telemetry systems. As Kay says, we have this working on remote telemetry platforms now at various baud rates, and that's all working fine.
Perfect. So the next one is interface. So if we type interface, it allows you to change between Modbus communications or keyboard communications.
So Modbus, all the commands for the Modbus are on our website. These follow the same command structure as the terminal mode. So you can send scan commands, or you can do read PH commands through the Modbus menu. It's been integrated now onto a number of Modbus 232485 platforms, and so it's quite smooth and easy. And we did a lot of work at the start of the year in making this better, and now it's very stable and robust. Any questions, please feel free to reach out to us, but it's working well.
It's worth saying, actually, if you're in Modbus and you want to get back to the keyboard communications, if you open utils, it automatically sends a command to get back to keyboard communications.
Yeah. So this can be done on any terminal program. A #702 command sends the sensor back from Modbus into terminal mode, allow you to reconfigure the sensor as you wish.
Okay, and then moving on Modbus there, you can also change the Modbus address, can't you, from that?
So all our sensors are either Modbus address 55 or the last 2 digits of the serial number. Obviously, if there's a conflict on a Modbus system, then you can change that address.
Perfect. Okay, so we move on to the measurement functions. So if you type immersion, it allows you to enable or disable the immersion sensor. So all the sensors now have an immersion sensor on them. So they'll only start scanning once the transducer surface is wet. This is really handy when you first get your sensor. The immersion sensor will be on, but if you want to test the comms on the bench without putting it into any water, you can turn the immersion sensor off and check the comms. There's also our customers use it for other applications, don't they?
Yeah, so the immersion sensor is really useful on remote platforms where maybe you're doing a wet or dry riverbed in estuarine environments, really where the water levels are changing. They've used it not just for the pH sensor itself, but they're looking at using it on their whole telemetry platform to know when they can switch on a multi-parameter sonde, for example, alongside their pH. They can use that as a way of detecting that instead of a traditional sort of conductivity sensor. So it's a very good way of doing it.
Perfect. Okay, so I'll leave it on for now by pressing 1. Go back to the menu. So the next measurement function is interval. So this allows you to change the time between measurements. So if we type in interval there, you see that, or has it disappeared down the bottom?
No, it's come
you
on.
can see that.
Yeah.
Okay, so if you so from the interval, if you do 3 zeros, that means it's continuous monitoring, and then you have the option to go from 15 minutes to 240 minutes.
Yeah, so for the interval delay, as Kay said, you can tune it yourself. When it's not measuring, it goes into a sleep mode, so a lower power consumption mode. So this works well for platform deployments.
And then we have our scan commands. So we have a scan O and a scan F. And these are currently for higher salinity waters and lower salinity waters. We also have an O1 and an F1, and that's if you want just to get one single measurement back and then to put the sensor to sleep in between. So again, this is for kind of the power consideration, isn't it?
Yeah, exactly. So we have customers now that have written terminal programs where they send a scan O, they power the sensor up, send a scan O1 command, it delivers a pH number back, and then they just turn the sensor off until their next measurement cycle. And as Kay said, it's all around power management of the sensor and of the whole platform.
Excellent. So if I typed in scan O now, then the sensor would just start scanning. I won't do that because it's just on the bench. But we have two sensors running in tanks, so we can show you that after. So the last two measurement functions are stop and shut down, which speak for themselves really. And then we have the data function results. So as Nathan said before, inside the sensor is an SD card, which saves all the sensor data. And this can be accessed by typing results. And you'll get a list of all the CSV files that are on the sensor, and then you're able to download them by just choosing the number. You can also do this from the utils main menu, if you remember from the beginning. If you choose option 2 on the main menu of utils, you can download the CSV data from the sensor. So there's two different ways of doing that. Okay, so I think that's all of utils. I hope you'll find it's really easy and intuitive to use. We tried to make it as simple as possible, and it's got all the functions in there that you could want. But now perhaps we can look at the sensor running and the sensor output.
Yes,
yeah,
let's do that.
Okay.
That's good. So we should say that utils automatically detects the baud rate on power up as well. So if you change the baud rate, utils will detect the power up, the baud rate, and configure to that baud rate. So it's all inbuilt within the utils program.
Did you want to explain the two tanks?
Yeah, I can do that. So in this demo today, we've got two tanks. We've got one in saltier water, sort of more closer to ocean water, and we've got one in fresh water. So we're going to show the scan O output and the scan F output. One on the utils program and one on a graphical user interface, which we'll go through. So this is the data coming out from the ocean sensor at the moment. You can see that we have a data string. A data string is obviously standard across our entire sensor range. In this string, we have a $A and B to identify it's an A and B sensor. We have a checksum, and we have code for the checksum in the website, on the output string website, which you can see. We then have the date and the time the measurement was taken. We have the pH returned. We have the temperature of the solution. And because this is outside of our current measurable salinity range, which is 0.3 to 7 ppt using the version 9 firmware, we output 99.99 where salinity and conductivity are placed. The next two zeros relate to the transducer and sensor health or diagnostics, and we'll show you why the sensor is smart and those outputs in a few minutes. The next zero is really a reserve byte. There's nothing in there. And that's because we believe that we're going to add extra functionality in the coming years, I should say, where we might output additional measurements from the sensor. 55 in this case is the Modbus address, and the last number, the 21, is the file that all the data is being saved to on the internal memory of the sensor. And this is consistent across all of our sensors, as I say. So it's really easy to integrate.
Okay, so we'll go a bit deeper into the health number now. So this really sets us apart from the glass electrode, because as Nathan said before, the sensor gives us feedback into what's going on and how healthy the transducer is and if any maintenance is required. And I think this is a game changer for the pH sensor. We've heard some horror stories, haven't we, of glass electrodes that have been deployed for weeks and weeks, giving the same number, so everything's fine. But then when they went to have a look at it, it was actually broken, but nobody knew. They didn't know how long it was broken for.
Exactly.
So yes, it's a really kind of key feature that the sensor gives you feedback onto how it's working. So if I just go to our website.
So the way the health is deduced is the sensor looks at all the signals that are being collected and computed against to get the pH output, looks at those signals and ensures that they're still discernible and that the pH sensing is still accurate within spec. If it starts to change and the signals start to change, then the sensor picks that up and will start to output a different health number. So as Kay said, it's really quite smart.
Smarter than me, I can't find the thing.
There we go.
Okay, so this is our website, our user guide, and it gives you all the information on the sensor output that Nathan just described before. And there's the CRC calculation. And then we get down to the pH, the salinity, and then the transducer health. So did you want to go through transducer health?
Yeah. So the transducer health, we have a range from 0 to 6. Obviously 0 is healthy, and you'll be pleased to see that the one in the ocean water is given a health of 0. 1 and 2 relate to some sort of transducer maintenance, and 3 as well. 4 is really interesting. That's our immersion detect sensor. As we say, we have people now using this to understand not just the sensor is immersed, but their whole deployment platform is immersed. We do an immersion check as soon as the sensor is switched on and the scan command is sent, or in autonomous mode, it starts to monitor. That immersion check is done straight away. If it's not immersed, a number 4 is returned in the health number, 99.99 in salinity, conductivity, and pH. And the sensor then switches itself off and goes to sleep mode and will wake up again after a predefined time to check again, or when you send another command. 5 and 6 are purely holding numbers, while the sensor adjusts some of its internal parameters.
Perfect. So maybe you can go into the maintenance now, the abrasion.
Yeah.
I'll stop the sharing.
That's
and
okay.
people will be able to see.
Yeah. So for transducer maintenance, if you get a 1, that means that you may need to maintain the transducer or abrade the transducers quite soon. 2 means that you should abrade really pretty much now. The way we do that is we take an abrasion block, which is on our which comes with the sensor. You need the Sharpie. The Sharpie doesn't come with the sensor. If you look on our website, there's a video about to do this, and I'm in a much more detail than I'm going to show you now. You basically put 2 dots on the surface of the transducer, on the top surface, only the top surface, the surface that sits proud. You put 2 dots, you take your abrasion block and just get quite a hard abrasion on the surface until those 2 dots are taken off, and then you repeat that, so you do that again. This can be done in the dry or in the wet in deployment. We have customers that have sent divers into the water to abrade the sensor underwater during a deployment to regain that lifetime back again. Abrasions typically are around every 15,000 measurements. The sensor tells you when it's required. We then move on to a health output of 3. A health output of 3 indicates that the transducer will be needed to be replaced. This occurs after around 20 abrasions, so you get 20 times 15,000 measurements per transducer. As an example, 15,000 measurements is around 5 days measurement time in continuous mode, around 54 days in 15-minute interval delays, and around 210 days in 1-hour delay mode. So if you're looking at a transducer on a 1-hour delay, it's going to last quite a few thousand days before we need to replace it. But when you do need to do it, as and when, that's quite simple too. The sensor comes with a clip on the surface. I'll bring this over here. This is the clip here. I haven't screwed this down for this demonstration just for speed. On the website, again, there's a way it will show you more details to it. You unscrew this clip and pull it off. You then get your transducer extraction device, otherwise known as a pure bottle opener, and you just pull the transducer off and prise it off like that. And then just using a little bit of force, you can just pop the transducer out. You get a spare transducer from us. Doesn't need any calibration. Everything is checked at factory before it's sent out to you. Once you get that transducer, you can just locate it on the key and then just pop it home with 2 simple clicks. And therefore, then it's done. No need to calibrate it again. It's ready to go. You may want to look at the video because there's extra steps in there around greasing the O-rings inside before you put that transducer in. And we supply grease to do that with as and when you need to do your transducer maintenance.
Perfect demonstration.
Close enough.
Okay, so that's the maintenance and the replacement of the transducer. I hope you can see it's very easy. Doesn't need to be, the replacement transducer doesn't need to be done very often, and it depends on your scanning profile, doesn't it?
Yeah.
So perhaps now we can look at the user interface and the freshwater sensor.
Yeah. So the freshwater sensor is running in this tank here. A graphical user interface will be released earlier on in 2024, and we've seen it's a really good uptake from customers, I would say. So it's a really nice way of visualizing the data that the sensor's taken out.
Yep, so the user interface can be found on our website. If you go to support, you can see the GUI there. There's a demonstration video and the download link here. So once you've downloaded it, if you unzip it and stick it on a folder on the desktop, you can run it from there. And here is our one running. So when you open it, you select your COM port, and then it gives you all the data from the sensor in the top box here. Over here on the status box, it gives you the transducer health and the sensor health. Again, so that'll tell you when it needs abrasion or replacing, and that box will go green if there's any problems. And then down on the graphs, you have the pH, the temperature, salinity, and conductivity. And I'll just quickly go through these top buttons. So obviously, you can start the measurement, stop the measurement, and shut down the sensor. This sensor settings button allows you to change the time and date, and also the measurement interval. So we're running continuous at the moment, but you can change it to have a delay, as we discussed earlier. The user interface settings allows you to remove some of these graphs if you don't want them on there, and it also allows you to set limits. So for example, in pH we've set the limits from 6 to 9, and you can see hopefully these green lines are the limits that we've set. In temperature we didn't set any limits, so this is the error that you'll see. This is the kind of warning you'll see if your measurement is outside your limits. So hopefully it's a really graphical kind of easy way of seeing if your pH or any of your metrics have gone out of the limits that you set. And finally, we have the log output view. So this is all the kind of output, just like you saw on utils, really, that the sensor's giving out. So that's also quite nice to look at sometimes. And as I said before, I think both the GUI and the utils program open a log file in the folder where the executable is, and that gives you all the output from the sensor from the minute you turned it on. So that's also quite useful to look back on. So yeah, hopefully you can see it's nice, easy to use, a nice method. We've had very good feedback on the user interface, haven't we?
It's a nice feature.
Yeah. So that's really all the main stuff about the sensor, isn't it?
Yep, that's it. And then we've got some added extras by Kay switched up the screens. So our added extras, obviously, easy integration and testing of the sensor through our data transfer unit allows you to connect it straight to a computer, plug it straight in, either pigtailed or subcom, and you can test it straight away. You can configure the sensor, put it in controlled autonomous mode, and set interval delays, start delays using that. You don't need to buy one per sensor. Multiple DTUs will do all the sensors and not configured per sensor, but you can plug multiple DTUs into a single laptop and run multiple sensors from a laptop as well, if you wish to. We have our flow cup here. We have customers that have bought these flow cups to place the sensor inside to run on the flow line. The sensor just slots into there, you screw the cap on, and you're allowed to run it. This goes to around 10 psi pressure, 10 bar pressure, sorry, for it to run. Obviously, spare transducers, all factory calibrated and sent straight out to you. You don't have to do anything with it, just pull out your old one and pop it straight in, as we said as well. For sort of buoy deployable customers who don't have any power, we also sell an intelligent battery monitoring system. This controls the power to the sensor and also saves all the data from the sensor to an SD card on board the IBM. This is good for lithium-ion batteries, where we look at the voltage on the battery and we ensure it doesn't go below the discharge voltage of the battery. So obviously once it's below discharge voltage, it won't recharge. So we make sure monitor the battery voltage and stop it before it goes below that. We also have inbuilt electronics there to really lower the power consumption of the sensor. So for a 28 amp hour battery on a 15-minute interval delay, you could get around 60 days of measurement. Obviously, you can multiplex them up, so you can get 120 days if you put two of those batteries together on a 15-minute interval delay. If you slow your interval delay down to an hour, you'll get 4 times that lifetime. So you can get a year deployment on an hour delay by combining 2 batteries with an intelligent battery monitoring system. Again, all the data is saved onto an SD card, which is easily retrieved from the IBM itself. Rather than downloading all that data, you just pull the data straight off.
Perfect. I think I might have forgotten to say at the beginning, if you've got any questions, please type them into the Q&A, which you'll find at the bottom of the screen. Yeah, please go ahead and just ask anything there, and we'll have a look at them afterwards. Sorry, I forgot to say that. Thank you. Okay, so now we just want to tell you a little bit about the integrations that we've done with customers, because we have many. Just need to share. Okay. Perfect. Did you want to go through these?
Yeah, so you can see, I mean, we've been around a while now, and we've done various tests, and this is sort of a great generation of product that we have now. We've really put a lot of development into this product over the years. This is now stable, easy to integrate and use. One of the features that we haven't mentioned during the webinar is our anti-biofouling measure. This is a natural byproduct of the reactions that we're doing, or the chemistry that we're doing when we're measuring pH. If we just look, really highlighting the data from UPC, where the sensor was put off the coast of Barcelona in Europe, we had 2 sensors deployed. One, the right-hand side, we didn't have that sensor switched on, so we call this their control. And we wanted to look at biogrowth on the sensor interface without having it switched on. You can see there's a lot of biogrowth. The one on the left, the sensor was switched on during the deployment. You can see there's no biogrowth on there compared to the one on the right. Uniquely, we generate a small amount of peroxide during our measurement sweep, which allows us to keep the transducer surface clean, our monitoring surface clean. The peroxide obviously it breaks down easily in water, but it's enough to keep it clean, and therefore we have an anti-biofouling inbuilt within the sensor.
Yeah, so just to be completely clear, both those sensors were down for the same amount of time at the same place. One was switched on and one was switched off. And by having it switched on and doing our measurements, we can keep our transducer clean from any biogrowth. Yeah. So it's like a massive kind of difference between sensors today.
Yeah.
Sorry.
No, that's good. No, that's fine. That's good. So if we just click on to the next slide. During the course of this year, we've been integrated onto a number of deployment platforms with various customers. With Alzheimer, we put it onto their Alcon autonomous underwater vehicle with a number of other sensors, where they're looking at CO2 coming out of a subsea volcano, so looking at pH changes there. With EWS, they've integrated onto their telemetry platform through a 485 Modbus communication protocol, and this was simple to do. With Sea Sigma, this is a completely wireless remote deployment platform underwater. So you can deploy both the sensor and the Sea Sigma EM2 system in the water. It will transmit data wirelessly from the EM2 to a surface station, allowing wireless communication. Our sensor is integrated onto the EM2 through a 232 terminal communication protocol, and you can control it from surface. EcoSub, we put the sensor onto the EcoSub system, showing the miniaturizability of the sensor. Metasphere, we have it on their RTU through our 485 Modbus protocols. And we can integrate onto a Slocum glider. We've written special firmware outputs which mimic that of a previously integrated CO2 sensor, whereas providing CO2, we actually give pH in the output stream. And this is through a 232 terminal communication program. And that's available on our version 9 firmware now.
So hopefully this shows you that it's very easy to integrate. We do actually have an integration kit, don't we?
Yeah.
So that we can change the kind of form factor to set the sensor in any kind of environment that you want to use it in. and all the communications can be worked out. We've done many, haven't we?
Yeah, exactly.
Okay, so the future plans for the sensor. Did you want to go through this?
Yeah, sure. So 0.3 PPT is very much a holding station on the version 9 firmware. In 3 weeks, we'll be releasing a lower salinity operation to get to around 0.05 PPT or 100 microsiemens per centimetre. That's our goal, and that's what we can achieve with our current development firmware. Incorporated in that firmware, we have a profiling mode to monitor pH changes quicker than the current firmware that we have now. Part of the uniqueness of the sensor and making it calibration free is the reference calibration check or the reference potential check. We understand that this is a downtime in pH measurement. We understand this could be power consuming, but it means that you don't need to send a field engineer to recalibrate your sensor. We're always looking at ways of speeding this up, and the next release will sped this up quite significantly. We know from customer feedback that Scan O and Scan F isn't always nice to have, because if people in estuarine or environments where the salt solution is changing, they have to flip that manually. In the next generation, post the 3-week delivery, we'll be looking at combining that into a single scan command. So all you do is send scan and it runs straight away. The 485 bootloader, currently our sensors only bootload through 232, and then we'll actually in the future release a bootloader you can do either through 232 or 485 COM systems. All of these will be done through firmware upgrades, no hardware upgrades. So we'll be releasing them on the website as we do now, and you can just download it, as Kay said, use the A and B utils to download the program and upload it onto the sensor. Really quite smooth, takes about 8 minutes to do for both the interface and driver boards.
Perfect. Okay, so just to briefly show you where you can get more information, if you go to our website, I think I showed you this before, but on the support section, you can find frequently asked questions, the link to download the GUI, and to the user guides. And the user guide looks like this. It's all the documentation, everything you could possibly want to know about the sensor, with links to videos. But of course, if you have any questions at all, there's our email address, our support email address. So please just drop us a line. We're always happy to answer your questions or jump on a meeting if it will help you. And then obviously the question on everybody's lips is where can you buy a sensor from? So again, on the website we have a sales tab, and here you can contact us directly for direct sales, or you can find your country in the list and the table, and in each one of those you'll find a distributor, details of our distributor or reseller partners in your country, and they'll all be very happy to help you. We've got a really good network of distributors and resellers, and we work closely with them. So yeah, they'll answer any of your questions and help you.
So this just sums it up really. Why are we different? We're calibration free compared to the classical glass pH electrodes that everyone uses today. We're multi-parameter. We output pH, salinity, conductivity and temperature into a single sensor. Hopefully we've shown that we're very easy to use. There's lots of functionality in the sensor. You can access it all through the utils program, and the menu is now self-explanatory. Lots of information on the website on how to use it. Anti-biofouling is unique in our sensor compared to a lot of the range. You don't need to incorporate your own biofouling measures. We cover the salinity range 0.3 to 40 ppt, and we're opening it out now. Easy to store. These sensors are stored wet or dry on the shelf. Easy enough, no worries. We log data internally on the sensor, so you have a backup system should your communication fail system. In our future releases, you'll be able to switch that off if you wish. It's up to you. Digital comms 232 485. We're intelligent. We give a smart output of the sensor, showing transducer health and when maintenance may be required or accuracy is lost within the sensor. We have patented the technology. Part of our development really early on was putting patents around the uniqueness of the technology, and therefore we are disruptive in the market, we believe.
Perfect, thank you. So if you've got any questions, I think that concludes everything we wanted to tell you. If you've got any questions, please write them in the Q&A bit at the bottom of the page. But maybe we could tell you a little bit about the warranty of the sensor while we see if there's any questions. So the sensors have a 24-month warranty. Put my paper here. The sensors and the DTU all have a 24-month warranty. The transducer has either 90 days or 10,000 scans, and the battery housings have a 12-month warranty. But please, get in touch if there's any questions.
So just on a question that we normally get, we're calibrated to a glass pH electrode, so we don't use total pH scale for the oceanographers out there. We're on a glass pH electrode scale, so that's IUPAT standards.
Yeah.
Cool.
Anything else? A question coming? No.
Lead times.
Lead times. So if you order your sensor today, you're looking at 8 weeks.
Yeah, 8 weeks.
For delivery. So.
Yeah. So we control their delivery schedule. We realised that earlier in the year that we were quite long on their lead times. That has been reduced. We've halved that lead time since the start of the year. And we're putting a number of processes in place internally on the manufacturing to reduce that further. And it will be coming down in the coming months.
Yeah. Brilliant.
No.
Okay, well, thank you ever so much for joining. I hope you found it useful. And again, if you have any questions, please get in touch.
Yeah.